students, today's agenda is to check homework. We'll be adding, subtracting, and multiplying complex numbers, and you will be able to do 1.2. Today, students will be able to add, subtract, and multiply complex numbers. Again, this is just like the first lesson, it's just review, so you're probably familiar with some of these concepts. And so for number 1, so we have here two complex numbers. A complex number is formed by a real portion and an imaginary portion. And so this is a complex number plus another complex number. When that's the case, all we have to do is just add the 7 and the 3. So 7 plus 3 is 10. And then 2i plus negative 3i. Well, if we have a positive and a negative, we subtract and leave the sign of the greater one. So it's negative I. Negative 1i, but you don't need to put the 1 as a coefficient. And so that will be your answer. When that's addition, we just combine like terms. However, we have here a subtraction of two complex numbers. And when that's the case, it's like if we had a negative 1 in here. And so you have to distribute that negative or negative 1 times each one of the terms on the second complex number. So the first one stays the same, 5 plus I. Just bring it down. And then in here, negative 1 times 3 is negative 3. Negative 1 times 3i is negative 3i. So as you can see, this is positive, it changes to negative because of that. This is positive, it changes to negative. Okay, so basically, when you are subtracting, all it does is change the signs of the terms inside of the parentheses. Now that we have them outside of the parentheses, we can combine like terms. So positive 5 and negative 3 is 2. Positive I and negative 3i, we subtract and leave the greater sign. So 3 minus 1 is 2. And the greater sign is negative, so negative 2i. And that will be my answer. In here, we don't have plus or minus in the middle. So when there is no plus and minus, that means multiplication. But when we have a minus or a plus, we have to respect that operation. Addition, subtraction, multiplication doesn't have a sign in the middle, okay? Some people see parentheses and they want to start multiplying. No, be careful. Look, if there is a sign, you have to subtract or use distributive property. Okay, in here, we're going to use double distributive property or FOIL. FOIL, just like we do with polynomials. So 4 times 1 is the first terms in each parenthesis. 4 times 1 is 4. Then O stands for outside. So it's the terms outside of the parentheses. So it's 4 times negative 9i is negative 36i. Then inside, I stands for inside. And so the inside terms is 2i times 1 is 2i. And L stands for last, which means the last terms on both parentheses. So it's the 2i and the negative 9i. So 2i times negative 9i is negative 18i squared. If you recall from the previous lesson, but if not, we'll review it in here. Anytime that you have I squared, that is equals to negative 1. So whenever you get I squared, you take that out and you replace it with negative 1. Okay, so we put negative 1 in here, and then we're going to multiply negative 1, which is that, the value of I squared, times negative 18 becomes positive 18. We bring everything else down just to keep ourselves organized, and then start combining like terms. In this case, we have positive 4 and positive 18. That I squared made that change its sign, okay? And we have negative 36i and positive 2i. I'm going to combine first the constant numbers. So 18 and 4 is 22. And then in here we have different signs, so we subtract and leave the greater sign. 36 minus 2 is 34, and the biggest sign is negative, so negative 34i. And that will be my answer. Okay, the next one, it's an imaginary number minus a complex number. Again, a complex number has a real portion and an imaginary portion. Again, this has a negative right before the parentheses. That means that I'm not going to multiply the imaginary number times this, but rather the negative 1. Okay, just the sign. And so we bring down the I. Negative 1 times 4 is negative 4. Remember that it just changes the sign. Negative times negative becomes positive 4i. Again, this was positive, now it's negative. This is negative, now it's positive. Okay, this made a change. We combine like terms. In this case, we only have one constant, but we have two imaginary portions. And so it's going to be negative 4. Positive 1i and positive 4i is going to be positive 5i. And that's my answer. Number 5, we have another multiplication because there is nothing in the middle. So that's, again, you can use FOIL, which I also call double distributive property, because you're distributing that multiplication with each one of the terms. First, outside, inside, last. Okay, so it can be called FOIL or it can be seen as double distributive property. You distribute the multiplication with the negative 6 first and then with negative I second. Okay, so, and I'll put it down here. Negative 6 times negative 2 is positive 12. Negative 6 times negative 2i is positive 12i. Now that second term, negative I times negative 2 is positive 2i. And negative I times negative 2i is positive, because negative times negative is positive, 2i squared. Again, we said that any time that you have I squared, okay, I squared is a negative 1. And if you think about it, we're multiplying that, because this is multiplication. We're multiplying that times positive 2. Let me bring it down in here as well. And so positive times negative is negative 2. Okay, so basically, if you notice, what this does is change the sign. So it disappears and it changes from positive to negative. Okay, that's something that I want you to notice. Okay, now that I have that, I can combine. Let's bring it down to keep ourselves organized. Combine constant numbers, so positive 12 and negative 2, because they don't have the variable. And we combine the 12i and the 2i. 12 minus 2, it's 10. And 12i plus 2i is 14i. And that will be my answer. In number 6, we're multiplying an imaginary number with a complex number. So it's just distributive property. 3i times 2 is 6i. Positive times negative is negative. 3i times 7i, 21i squared. This I squared becomes negative 1. And we multiply it times the negative 21. Bring this down to keep ourselves organized. And negative times negative becomes positive. Positive 21. And we bring down the 6i. So it's 6i plus 21. Now if we want to write it properly, it would be 21 plus 6i. Complex numbers are written in this form with the real portion first and the imaginary portion second. For the next one, some people will say, oh, it's just 3 squared and negative I squared. But no, we have to actually write it down and start spreading, or you can just remember the rule of a squared plus 2ab plus b squared. That's also the formula or rule for perfect squares, okay? And what this means is that you square the first one, so 3 times 3 will be 9. Let me do it over here with the shortcut. 2ab means multiply the first term with the second, so 3 times negative I is negative 3i, and double it, multiply it by 2, so it will be negative 6i. And then b squared means the second term multiplied by itself. Negative I times negative I is positive I squared. This is like we have a 1 in here. Again, I squared means negative 1 times the positive. Positive times negative is negative 1. Bring down the rest, so 9 minus 6i. Combine like terms. 9 minus 1 is 8 minus 6i. So that will be the answer. Now let me show you with by writing it down. Again, when you're squaring something, it means that base multiplied by itself 2 times. And so that's why I'm writing it 2 times. You do the distributive property or FOIL. So 3 times 3 is 9. 3 times negative I is negative 3i. Negative I times 3 is negative 3i. And negative I times negative I becomes positive I squared. I want you to notice how these are similar for the first and last term. And then the middle, the 2 terms in here become that double, right? It's always going to be the same, 2 of the same. That's why they say twice AB, okay? Okay, so we combine like terms. And at the same time, we change this. So I squared becomes negative 1. And positive times negative becomes negative 1. Bring down the 9. Negative 3i and negative 3i becomes negative 6i. Now we combine like terms again. Positive 9 and negative 1 becomes 8 minus 6i. And yes, this is shorter, but you do have to remember that formula if you would like to apply. Okay, number 8. And here we have subtraction. And so the first term or the first complex number, you just bring it down the way it is. In here we multiply by negative 1. So negative 1 times 5 is negative 5. Negative 1 times 2i is negative 2i. Then we combine like terms. Constant numbers with constant numbers, and imaginary with imaginary. 1 minus 5 is negative 4, because remember, when the signs are different, we subtract and leave the greater sign. And now we have 2 negatives. When we have the same sign, we add them and keep the common sign. So negative 3i and negative 2i is negative 5i. And that will be the answer for this subtraction or difference of complex numbers. Again, in addition, some people prefer to bring it down. Remember that if it's addition, you just bring it the way they are for both terms or both complex numbers. If not, you can just start combining this with the 5 with the 1 and the negative 3i with the 2i. Okay, that's perfectly fine. So 5 and positive 1, it's 6. Negative 3i and positive 2i is negative I, because we subtract and keep the greater sign. Okay, so that's the answer, 6 minus I. That's all for this lesson, and if you can please give us a thumbs up, subscribe around here. Here is the link for the entire unit. Here is the next lesson. Now you're able to do 1.2 and have fun.